This time we're going to be doing some reaction stoichiometry with a sequence. Sometimes when we are making a product, we can't make it directly. We have to do a series of chemical reactions. Now this is called a reaction sequence, and this happens for most industrial processes. Now, the series of reactions we have here is the reaction sequence for producing sulfuric acid at the Kalgoorlie nickel smelter. You can see there are 3 reactions involved. Now, the main purpose of the Kalgoorlie nickel smelter is to make nickel, and that's, you can see, the first reaction. That makes nickel. What we do is we roast the nickel ore and we produce nickel. Now, a byproduct of this reaction is sulfur dioxide gas. Now, the Australian government has told industry they are not allowed to dump sulfur dioxide into the atmosphere because sulfur dioxide in the atmosphere can combine with water to form sulfuric acid, which is one of the main causes of acid rain. So, at the Kalgoorlie nickel smelter, they have to recover the sulfur dioxide gas. Now, once they've recovered their sulfur dioxide gas, they react it with further oxygen to produce sulfur trioxide. The sulfur trioxide then is absorbed into concentrated sulfuric acid, which is then added to water to make sulfuric acid. Now this occurs in 3 reactions. So this is considered to be a reaction sequence for the production of sulfuric acid. Now once again, it is just a stoichiometry. You still need to identify the data. We have to play with our balanced chemical equation a little bit. We are going to identify the known and the unknown. We need to find the moles of the known, and then using our balanced chemical equation, find the moles of the unknown and find the mass of the unknown. Now in this question, we've been told we're going to find the mass of sulfuric acid in 1,000 kilograms of nickel sulfide. Now already there should be some alarm bells going off because we've got 1,000 kilograms. So one of the early things you're going to have to do is convert this to grams. Now, we have a balanced chemical reaction. In fact, we've got 3. But this is going to cause us a few issues because when we want to do our mole-to-mole ratio, we're going to have to find, okay, we've got this as our known and this is our unknown. That means that you would need to do a stoichiometric ratio to find how much sulfur dioxide you've got, which must all be consumed, and then do another stoichiometric ratio to find out how much sulfur trioxide you've got, and that's all going to be consumed, and then do another stoichiometric ratio to find out how much sulfuric acid is produced. Now that means you've done 1, 2, 3 stoichiometric ratios. Well, that's a bit of a pain. So let's try an alternative way. What we're going to do instead is we're going to say, well, these are all just balanced chemical equations. We want to be able to relate directly this known to this unknown. Now the way we can do that is we can make the moles between here and here, the coefficients, the same. And this will allow us to directly relate the known to our unknown. So how do we do that? We can see here that 2 moles of sulfur dioxide produce 2 moles of sulfur trioxide. And we know that all of that sulfur dioxide came from equation 1. So these are balanced chemical equations. If I multiply this by 2, this would mean I've got 2, 2, 2, and 2. It's still a balanced chemical equation. It's just not at the lowest ratio. But now, however, I've got all of these sulfur dioxides here have the same coefficients as the sulfur dioxide here. So at this point in time, I can now relate this directly to this. So I need to be able to now make these ones' coefficients the same. So this one here had 2, this one was 1. So if I multiply this reaction by 2, 2, 2, and 2, now I can relate, as these coefficients here are the same, I can now relate directly my known to my unknown. Okay, now that our equation is ready, we've got a mass known, we now have to find the moles known. Now to do that, we have to use number of moles equals mass over formula mass, and this will convert us to moles known. Okay, so our equation is now ready. We've worked out what our known and our unknown are. Now we can start with the actual question. We want to find the mass of sulfuric acid with 1,000 kilograms of nickel sulfide. Now remember previously we said we had to convert the grams into kilograms. So that's the first thing I'm going to do. I'm going to say the mass of nickel sulfide is 1,000 kilograms. Now I have to convert that to grams, so I'm going to multiply by 1,000, which is equal to 1,000,000 grams. Now that we've got our mass in grams, we can actually find the number of moles. So the number of moles of nickel sulfide is equal to a mass over a formula mass. I always tell my marker what I'm doing. My mass was 1,000,000 divided by the formula mass for nickel sulfide, which we have to get off the periodic table, which is 90.76, which comes out to 11018.07 moles. Now we'd expect it to be a very large quantity because this is an industrial process. No one in industry makes very small quantities. Okay, we've now got our moles known. We can now convert to our moles unknown because we have a balanced chemical equation. We've got 3, but we've adjusted the ratio so that we can go directly from a known to an unknown. So we'll be able to produce our stoichiometric ratio. Okay, so now that we've got our moles, we're going to find our stoichiometric ratio for the moles of the unknown. So we're going to go the number of moles of sulfuric acid will equal unknown over known times by the moles that you know, and the moles that we know is nickel sulfide. So the unknown is 2. So the coefficient of the unknown was 2. The coefficient of the known is 2. Times by the number of moles of nickel sulfide, which is 11018.07, and it comes out to 11018.07 moles of sulfuric acid. Now we are here. We have our moles of our unknown. So the next step is we've got to find our mass of our unknown. Now to do that, we're going to do a rearrangement of the number of moles equals mass over formula mass to determine the mass of the sulfuric acid. Our final step of this stoichiometry is now to find the mass of the unknown. So the mass of sulfuric acid is equal to the number of moles times the formula mass. The number of moles was 11018.07 times the formula mass of 98.086, and this comes out to 1080718 grams. Now our original number was given in 4 significant figures, So our answer should also be in 4 significant figures. So this is 1.081 by 10 to the 6 grams, or because we were given the question in kilograms, this is equivalent to 1.081 by 10 to the 3 kilograms. Now you need to try one for yourself. I'd like you to go to your OneNote, chemistry calculations, stoichiometry, sequence calculations, and try the calculation. Once you've finished, you can check out the YouTube link below and see how well you went.